Hey everybody. Alright, so we've reached a point in the rocket build where I'm waiting for the primer to finally set. I mean, it is set, but letting things just sit for a little bit until I get a good open day to set everything up for the final paint job. So I figured it'd be kind of a cool time to show you on the kind of tech side, like what have I kind of had to learn during this process. A lot of this was very new to me. It's really accessible. I can have some links below the video to some of the things that I used here to really help me prep for what motor I need, not only the mentorship from the local group I'm a part of, but also running simulations for those models, and based on the weight of my rocket, kind of the outline of it, where like basically making a full scale model of the rocket itself in a program called Open Rocket. So I'll show you a piece of that. By no means is this going to be a tutorial, I'm just giving you some info about what I did and kind of where to find it, and kind of figure some of this stuff out on your own too if you're interested. And then admittedly I went a little bougie with it and got a GPS system for this, just because I was like, it'd be a real shame if it went way high up in the sky any of the times we use it and suddenly lost it. So anyway, went ahead and found a way to do that. I won't be able to show you because I'm filming on my phone how that shows up on the phone live, but I can show some pictures and I'll kind of walk us through that. So the other thing that I got is a chute release, but I'm not going to be using it for the first launch. It was ill-advised from the mentors. They were like, don't add more technicality on this first one if you don't need it. Fair enough, I'll save it for future things. So here we go. I'll show you some of the cool stuff. All right, so this here is our Open Rocket program. You'll see down there, that's the little icon it has. It's a free download online, pretty easy to find, okay? And so, you know, I'll say the first time I did this, you know, I had tried to make a version from scratch. I made a full one, and then I was like, actually, let's look up and see if there's any already online in some kind of forum, like, because it's open source, people just share things, of the xylofoxylin rocket. There was, and I actually then downloaded that. Found out that my version was pretty close, but the person who made that one was clearly more experienced, so I actually ended up taking that and then customizing it to fit all the specs that mine actually differentiated from the main build on, including these extra things I'm going to show you, but also some of my weight distributions and grams and all that kind of fun stuff. So anyway, so what you do is you go up here and let's see, I want to open. All right, and mine is kind of, I named it like Misfire Naomi Data Finalized Rocket. And so this is kind of what you'll see. So over here, you have all these different parts breakdown, including the weights that you give them. It looks more complicated than it is. I mean, you know, again, other people are savvy at this way more than I am. You can get really in depth with it. But admittedly, with some tinkering around and a willingness to learn, it's really accessible. So anyway, and this right here, you can click on different parts and it'll kind of tell you what's going on. You can even kind of go over and change the type of view. So if I wanted 3D figure, it kind of gives you this, which is kind of neat. And you can turn it, get like a view of all the neat different angles of it and whatnot. So, but let's go back to our side view, okay? And right now, this little chunk right here is accounting for the motor I've chosen, okay? Which right now, if I go up to motor configurations, what I have it set to is an H100 DMS, and I have it set to the idealized, per my models, 8 seconds, okay? Again, and that was based on the simulations that I was running, okay? So for instance, if I hit run sim, okay, and then up here, I hit plot. Well, actually, I don't want to export, so why don't I just plot, okay? What it's doing is it's telling me the altitude at which it's going to slow down enough for an idealized chute release, okay? And it anticipates basically based on, I put in like the latitude, longitude, where we're going to be, elevations, all that stuff, and it tries to calculate, anticipate, based on a number of factors, how long it's going to take to reach the ground. at what rate it's going to fall, and that sort of fun stuff. So again, this is essentially what you're looking for is you want to make sure that these numbers up here are saying that A, it's going to take off fast enough, which it is, that it's going to give you an anticipated height for this launch. Kind of conservative, you know, with an H100, because low and slow is the way to be, so I hear, on your first try to be level 1 certified. And then velocity at the deployment, so you don't want it to be going so fast when it chute releases that it just rips itself apart. So anyway, and it gives you like kind of max speed. So this is, you know, a nice way to kind of test and see, including important things like your center of gravity, right? Kind of if you were to balance the rocket, that like on your hand, right? That's where the weight would be distributed after you load the motor in. And then the center of pressure. Now, I'm not a rocket scientist, so I won't try to explain that a ton here, and it's a complicated mathematical equation to get there, hence the simulation helping us out. But ideally you want your center of pressure to be, you know, lower back on the rocket than your center of gravity, and there's a certain metric in which you want it to be. Right now we're in good shape, and essentially the center of pressure, I'm going to butcher this and someone in the comments is going to get me for it, but my understanding is it is the point in which the rocket is taking the most aerodynamic, or aerodynamic pressure, essentially, like all the forces of wind and other things are basically impacting that the most during flight. So it's hard to measure that when it's standing still. They used to do it in wind tunnels for the most part. But again, this is all new knowledge for me, and learning as I go. So the mentors in the local group have been helpful with sort of checking my numbers with me on this and making sure that my setup is actually the way you want it to be. All right, let's take a look at the GPS system I chose. So I decided to go with Featherweight altimeters. And this is the ground unit. So what you're going to do is this and the unit here that is attached during flight. Now, and I'll talk about the case in a moment. But essentially, this is a two-part system. So you have your ground unit here. You like hold on to this. You turn it on, of course, before the flight, okay? And it connects via Bluetooth to an app on your phone that'll give you tons of data, including very detailed map and track it in real time and give you a place to find, like go search for the rocket if you need to. And it lasts for like 20 plus some odd hours if you needed to at full charge. And then also the flight unit is in here. So let me kind of pull this out for you here. Okay, we're back. I had to take some additional screws out. Now, our ground unit, you can see here, or I mean the flight unit, ground unit, flight unit, okay? Now this nifty looking thing, okay, you can see is connected to another LiPo battery that is on the lower end of this here, see? And what this does is you click it on, see, on, there's a little switch right there, okay? And then this will be emitting a constant signal, okay? So this shoots up, you attach this, via, those lines there, those like indents, you put it on your recovery line, and you seal this up. This is by a third party who, let's see if we can see it. There it is. It's Featherweight GPS, Inverted Pursuits Lab. So it's a private guy that makes these 3D printed capsules. They're pretty awesome. You can find it online, just Google that. And this all locks in here and is very secure, and it will, when it shoots up into the sky, essentially that'll continue to emit a signal. This will continue to pick up that signal, and this also relays to that Bluetooth via app on your phone. It doesn't require any kind of cell signal, Wi-Fi, anything like that, so it works when you're quite remote, okay? And so it allows you to just walk with this and follow a map directly to wherever your rocket has landed. And again, if you lose it, batteries can last upwards of for longer than a day or so, okay? Anyway, so that is kind of what you're looking at here. The last part here in terms of tech, and this isn't something I'm going to use on my first, on my level 1 certification flight per recommendation from the mentors in the group, but this is the Jolly Logic chute release, and so I figured this would be a good thing for later down the road. So pretty nifty thing here, kind of simple mechanism too. So this little thing, this is just a charging cord for it. It comes with rubber bands. There's more underneath this tray, like it says, the tether cord itself, and you get some extras, and of course, some primary and spare pins. But this nifty little thing, essentially, what it does is this tether here, you make sure that that's tied down real good to your recovery lines and stuff so you don't lose this module, okay? And then here, what you do is you can essentially turn it on, okay? And right now you can see it's set to like 700 feet, or actually 600, it's set to 600 feet. So that would mean it would shoot way up in the sky, and then as it's declining, it can tell when it's reached 600 feet, and this little pin releases, okay? You can see on this side, okay, this rubber band here, what you do is you would wrap this around your tightened parachute. You see that little pin? Okay, that sticks inside that hole right there. And once it has fallen, okay, to the threshold you've chosen here, then a little mechanism in there releases that pin, and boop, the rubber band pops off and releases your chute. So it allows essentially your whole unit to free fall until the height you've chosen, and then which point releases the chute and then falls safe with the ground. This can help you if your rocket goes several thousand feet in the air and you don't want it to catch a high wind up there somewhere and drift forever away. So anyway, neat little thing, and there's a way you can test it as well, but I won't go through all that. So that's what we've been up to on the tech side, and it's a fun little bit to get involved in if you want to, but it's not really necessary. You know, the open rocket thing is free. I'd say that might be more necessary or more fun, or, you know, might actually be very helpful. You know, the GPS thing and the Jolly Logic thing, that's just superfluous, but I just chose to do it anyway. But anyway, hope y'all enjoyed the video, and we'll have more coming up soon. Our actual launch is going to be probably, it's still like another month or more from now, waiting on the engine to come in. We ordered it, but it's on backlog, so it'll be here. Talk to you later. Bye.